Okay, so this video is all about polygon angle sum theorem, and it's really easy. The main idea is that the sum of the interior angle measures depends on the number of sides of the polygon. So the more of sides, the higher the number is of the measures. It'll make sense. For example, if you have a triangle, the sum adds up to 180. If you have a quadrilateral, which is 4 sides, it adds up to 360. A pentagon, which is 5 sides, adds up to 540, and so forth. So what you really find out is every time you add a side, you add 180 degrees. But there is a formula, and we are going to use it, because if it was 17 sides, you wouldn't want to start with a triangle and then add 180. So it becomes easier when you have a formula. We do have 3 new vocabulary words that we need to know. Equilateral polygon, equiangular polygon, and a regular polygon. So the polygon angle sum theorem, that's actually hard to say, says the sum of the measures of interior angles of an n-gon, meaning any side, is the number of sides minus 2 times 180, which is right here. So however many sides it is, you take that number, subtract 2, and then multiply it by 180. So they give us an example, so let's read it and we'll follow along and then we'll do one of our own. And it says, how many sides does a heptagon have? And a heptagon has 7 sides. So it says, what's the sum of the interior angle measures of a heptagon? So a heptagon has 7 sides, so we're going to plug 7 in for n. So 7 minus 2 is 5. 5 times 180 is 900. So the answer would be 900 degrees. So the sum of the interior angle measures of a heptagon is 900 degrees actually. That's our answer. And that's what we're going to do. So before we go over an example, let's go over the new vocabulary. An equilateral polygon is a polygon with all the sides congruent, meaning that they're all the same sides. And don't forget, whenever it's marked, these markings mean congruent. And so just to be really, really clear, if this was 8, then they would all be 8. Okay, that's what congruent means. They're all equal measures. And an equiangular polygon is a polygon with all the angles congruent. And the last one is really important because a regular polygon doesn't sound like it would be very special, but it's actually a really special polygon because it's a polygon that's both equilateral and equiangular. And they never mention it again. When they say a regular polygon, you're just expected to know that forever. So be really, really careful. If someone says it's a regular polygon, you're just expected to know that immediately. So really, really pay attention and listen for the word regular. If it's a regular octagon, regular pentagon, something like that, you're looking for the word regular because it actually has meaning. Okay, so let's do an example. And they want to know what the measure of y is in the pentagon today. Well, the first thing that we have to figure out is what should they all add up to be? And so pentagons, if you don't know, they're 5-sided. But if we didn't know, we could just count the sides. So 1, 2, 3, 4, 5. So there's 5 sides. Okay, so that would be 5 minus 2 times 180. So that would be 3 times 180. Well, 3 times 180 is 540. So all of these numbers should add up to 540. That's where we are right now. So what we're going to do is we're going to take all of these numbers and subtract them from 540. So we have 110, we have 150, we have 120, and we have 90. And whatever's missing is this angle right here. And that's what we're looking for, because that's what they're asking us for. What's the measure of angle Y? So we're going to get our calculator out, and we're just going to do this problem. And you can do it all at once. Just take 540 minus 110 minus 150 minus 120 minus 90 and hit enter. And that'll tell you the answer. So when you do all that, you get 70. And so that's the measure of angle Y. And don't forget, that literally is what it reads. So when you write it, you could write the measure of angle Y is 70 degrees. Okay, so try G by yourself. You know, what should they add up to be? How much should those angles be to start with? And then back in to what it would be. Okay, so if you haven't solved G yet, go ahead and pause the video now and do it by yourself first. Always try to do them by yourself first and see what you think, and then watch the video and see if you got it right. Alright, this is a quadrilateral because it has 1, 2, 3, 4 sides. And it does not have to be equal, like it doesn't matter that they're different side lengths. So it's a 4-sided figure. And so that would be 2 times 180, because 4 minus 2 is 2. And so this should add up to 360 degrees. So all 4 of these angles, and this missing angle we don't know, that's what we're asking for. Notice that it asks for G. So we're going to start with 360, because that's what they should add up to be. 360 minus 120 minus 85 minus 53. And whatever that is, that has to be the missing piece. So in your calculator, put 360 minus 120 minus 85 minus 53, hit enter, and you should get 102 degrees. And that has to be the measure of angle G. So you could even write it, the measure of angle G is 102 degrees. Okay, moving right along. One of the cool things in geometry is that no matter how many sides a polygon has, the exterior angles always add up to 360. So notice the triangle here in this example. If we extend the lines, these two add up to 180. 30 and 150 is 180. And then these two add up to 180. 80 and 100 add up to 180. And then these two add up to 180. 50 and 130 add up to 180. But more importantly, 80 and 130 and 150 all add up to 360. And the same thing is true over here. All of these add up to 180. But even more than that, all of the exterior, when you add them, they all add up to 360. And that's always true. Always, always, always. No matter what. Doesn't matter if it's an octagon or a pentagon or a triangle. It doesn't matter. The exterior angles will always add up to 360. And it has something to do with the extension of the lines and the properties of the straight lines. But we use that to help us with the exterior angle sum theorem. And it's kind of, I think it's interesting, because even though we just did all this work, we used this formula here to find out the interior angles. We don't need that formula for the exterior. The exterior is always going to be 360. We don't have to even do any work. The exterior sum will always be 360. Now the interior sum, we don't know. We actually have to figure it out. It could be 540, it could be 360, it could be 900, you know, we don't know. But the exterior sum, it'll always be 360. But what we don't know is what each one is individually. Now that requires a little bit of work. And unless it's a regular polygon, like, remember that regular polygon actually is special, we will never know. Like, if it's like this, we would never be able to figure it out without more information. But if it's a regular polygon, meaning that all the answers are the same number, we won't know what it is. But they will make it easy on us, and we will be able to figure it out. So let's just, we'll do one, and now it'll make more sense. So the next theorem that we have to learn says the exterior angle polygon exterior angle sum theorem. And it says that the sum of the measures of the exterior angles of polygon, one at each vertex, is 360, and it's always 360. So if you take angle 1, 2, 3, 4, 5, and add them up, it's going to be 360. And it would always be that. If even here, 1, 2, 3, 4, 5, 6, 7, 8, they're going to be 362. No matter what the polygon looks like. If it's a regular polygon, you can actually figure out the measure of each of those, which is what we're going to do here. Notice again, it tells us it's a regular octagon, which is huge. If they don't tell us it's a regular octagon, we cannot do anything. If it just says it's an octagon, then we say, we can't tell you for sure, you know, we don't know the answer. We don't have enough information. But if it says it's a regular octagon, then we can say, oh, based on that, now we can solve it. Okay? They did give us enough information. So because it's a regular octagon, that means that all the angle measures are the exact same number. So number 1 is the same as number 2, and same as number 3, and so forth. So if they all add up to 360, and there are 8 of them, then that means I can take 360 and divide it by 8. And that'll be the same answer for all 8 of them. And 360 divided by 8 is 45 degrees. So here's what I know. I know that angle 1 is 45 degrees, and so is angle 2, and 3, and 4, and so forth, okay, all the way around. And I only know that because they told me it's a regular octagon. Otherwise, I don't know that, and I cannot do this work. So let's do the next one. Try it by yourself. And if you need help, ask for help. Okay, if you don't know, a nonagon is a 9-sided shape. Okay, so 9-sided. And again, they had to tell us it's a regular one, or we can't do anything. And they also have to tell us, since they didn't draw us a picture, they have to tell us either that we're looking for the exterior or that we're looking for the interior. Otherwise, we don't know. You know, if we're looking for the interior, we have different work to do. So the exterior, we know we're going to start with 360. So exterior, we're going to start with 360. The fact that it's a regular nonagon means that they're all the same. So we're just going to take 360 and divide it by 9. So 360 divided by 9 is 40 degrees. So each of the measures, each of the exterior angles are 40 degrees. All of them. And that's it. That's our answer.